Hi, welcome back to another episode of Algebra and Words, the video series. Where we left off in the last videos, we were doing linear equations. And we were mainly looking at one linear equation at a time. So we're going to take that a step further in this section, and we're going to look at systems of two linear equations. Okay? So this video is going to be more of an overview, an introduction into that, and then in later videos we'll do some actual examples. So the first thing that I want to discuss is, what is it? What is a system of two linear equations? A system of equations is when you have multiple equations, or mainly their graphs, on one graph. So what I have here is just a sample graph with two lines representing two linear equations on the same graph. Okay? A system of two linear equations means two lines on the same graph. Okay, and next question is, so when you do a system of two linear equations, what's the goal? What's the solution? The solution is a point. So I'm just going to write a generic point . X, Y. There's two parts to this. There's an X value and a Y value. Alright, and that's why these type of problems are unique, because normally we're used to solving maybe for X, maybe we get one answer, and in this case we're solving a value for X and its associated Y. Okay? And also, what does the point represent? The point represents the area or the place on the graph where the two lines meet. And in the place where the two lines meet or intersect, they'll have one common point that they both share. And that's the solution to a system of two linear equations. Now, there's four methods that we use to solve a system of two linear equations. And I have them listed here. One method is called graph and check. Another method is called the substitution method. Another method is called the addition-elimination method. And a fourth method you can solve using matrices. So let me give a brief overview of each one, and then we'll do some example problems in the next videos. So first of all, we have graph and check. Now, in the book, you will likely see problems that might have them split up. For example, one type might show you a graph. You have to read and interpret the graph. Look for a point that you think they intersect at. Then you take the values of those points, you plug it into both equations, you simplify, and if the left side equals the right side for both equations, then that's a sign that tells you the point that you read on the graph and checked in the equations is the solution. So that's one form of graph and check. Another form is, okay, in more of the basic problems, they may just give you a sample point, an XY point. And you have to take the X and substitute the value of X into X and the value of Y into Y into both of the given equations. And again, simplify as much as you can. And if the left side equals the right side for both equations, then that tells you that the sample point that you're testing is the answer to the problem. Alright? Finally, you could be given a question like this. You're only given the two equations and basically nothing else. And from there, you'd be responsible for graphing both equations on the same graph, and then looking at it, trying to find the point where they cross and interpreting it as best you can, and then taking the values of the X and Y and substituting them into both of the original equations. And once again, if the left side equals the right side for both equations when simplified, then that tells you that the point that you are testing is the answer. Like I said, I'll dedicate a video just to the graph and check method and various types of questions that you could get from that. Another method is the substitution method. Again, we'll do videos just for that, and in that, you rearrange one of the equations and you substitute whatever one of the variables equals in for that variable in the other equation and continue from there. I'll explain that in the next video. Another type, and by the way, these are all just a random order. There's not a specified order of 1 through 4, but these are just random order. A third type I call the addition-elimination method. All right? And when people see that at first, they wonder, why is it the addition-elimination method? Well, the reason why I call it that is, first of all, each textbook, some call it the addition method, some call it the elimination method. It's the same thing. When I show you the procedure in a later video, you'll see that one step is adding the equations once they're ready to be added. When you add them, if you did it appropriately, then you'll eliminate terms of the same variable, eliminating one variable, leaving you with the other variable, and once you have the one variable, you can solve that equal to a number, and then once you have that, you can substitute that into the originals to solve for the other variable, the one that you canceled out originally. Alright? And I'll come back to a word I want to say about that after we look at the fourth method. The fourth method is matrices. You can solve a system of two linear equations using matrices. Now, in the next few videos, these are going to be more dedicated just to the first three methods because these are closely associated with doing our lesson in linear equations. Matrices is not quite linear equation math, although of course it's related. But if I do matrices, that'll be in videos much later. I have them numbered, so it'll be in a much later episode. But anyway, I said that I wanted to say a word about addition and elimination, as well as even substitution. Okay, and something that's very important to know, it's just a basic thing. In algebra, you need as many equations as you have unknown variables to solve. So for example, in the previous videos, and we weren't quite solving for x, but sometimes we solve for x. If you have an equation where you're solving for x, you need one equation because x is one unknown variable. So you need one equation to solve for x. However, in a system of linear equations where we need to solve the values of two variables, again, you need as many equations as you have unknown variables. So if we're solving for two unknown variables, we need two equations. And that's another reason what makes this a system of linear equations. And that's why we're going to utilize these methods, mainly the substitution method and the addition-elimination method, to solve for, certain methods to solve for one variable, and once you get the value of one variable, then you use that to solve for the value of the other variable. So that's an important thing to keep in mind. That's all I have to say for this video. In the next video, we're going to do one video for graph and check, one video of substitution, and one video of addition-elimination method. And like I said, matrices is something that we'll maybe cover in a later episode. But anyway, I hope you found this helpful and useful. Most textbooks don't go into the explanations that I just gave on this as much. So I hope you found this useful. If you did, please give a thumbs up. Please share with your friends. And please subscribe to the channel. And please look for other videos on my Facebook and Instagram channel. And I'll see you in the next video.